Hello students and everyone, this is Gaurav Mishra and I welcome you all to GM Physics. Alright, so let me introduce you with today's video lecture. This video lecture is all about the Polygon law of vector addition. And let me tell you, this is part 4 under addition of vectors. Under addition of vectors, we have already done part 1, part 2 and part 3, where we have discussed in part 1 what is addition of vectors, what it really means to add vector quantities, means that is simply an introduction to addition of vectors. Then in part 2, we have talked about the various laws of addition of vectors, where we have covered the parallelogram law of addition of vectors in detail, not other laws. Then in part 3, we have talked about the triangle law of vector addition in detail. Now this is part 4 of addition of vectors, where we are going to talk about the Polygon law of vector addition. Alright, so let's look at the sequence of this video lecture quickly. So the first in the sequence will be, what is the Polygon law of addition of vectors? Means we'll discuss what is the statement of this Polygon law, how do we apply this Polygon law for adding vector quantities, right? Then in second section of this video lecture, that is next in the sequence, we'll see how do we get this Polygon law of vector addition. Means what is the proof of this law? We'll be proving the Polygon law of vector addition in the second section. And then in the third or final section of this video lecture, we'll have some solved examples to see how do we apply this Polygon law in real problems. Alright, so let's begin. Alright, so what is Polygon law of vector addition? What is the statement of this Polygon law? How do we use this law? How do we apply this law for adding vector quantities? How many vectors can we add using Polygon law of vector addition? Is it 3 vectors, 4 vectors, 5 vectors, 10 vectors, 50 vectors, 100,000, million? How many vectors can we add using Polygon law of vector addition? Is it necessary that vectors must be coplanar for applying Polygon law of vector addition? Like in triangle law of vector addition, the vectors used to be in the same order, right? Then the third side in the opposite order was the resultant of the two vectors. So same like triangle of addition of vectors, do we need vectors to be in the same order, right? And if it is like that, then if the vectors are not in the same order, can't we use Polygon law of vector addition? Only if we are given that vectors are in the same order, then only will we be able to apply Polygon law of vector addition? All these questions will answer in this discussion. So let's try to find out what is Polygon law of vector addition. How do we apply this law? And for that case, I've taken the simplest case possible. Here I have taken 3 vectors. And you can see there is a pattern in which these vectors are arranged. The head of the first vector and the tail of the second vector lie at the same point. Again, the head of the second vector and the tail of the third vector lie at the same point. Means tail, head, tail, head, tail, head. There is a pattern, there is an order. So this is what we call vectors arranged in the same order. So here we have 3 vectors. Let's call them, this is A1 vector, this is A2 vector, and this is A3 vector. So what you see here, that all these 3 vectors, A1 vector, A2 vector and A3 vector, they are arranged in the same order, right? And we want to add these 3 vectors using Polygon law of vector addition. So we want to add these 3 vectors, A1 vector, A2 vector and A3 vector. by using Polygon law vector addition. So what we want to find is A1 vector plus A2 vector plus A3 vector, right? And how we will get it? By using Polygon law vector addition. So let's try to understand this Polygon law in the process itself while I am adding these three vector quantities, A1 vector, A2 vector and A3 vector, right? So the first thing Polygon law says that the vectors must be in the same order, like in this case, tail head, tail head, tail head. So the thing is, the head of one should be at the tail of the other. Again, the head of the second one should be at the tail of the third. Again, the head of the third should be at the tail of the fourth, and so on. As many vectors are there. Are you getting it? So here we have taken only three vectors, A1 vector, A2 vector and A3 vector. So the first thing is, the vectors must be in the same order. So let's write it in the same order. This is the first and the most important thing that must be checked before applying Polygon law of vector addition. So vectors must be in the same order. Alright, so now Polygon law of vector addition becomes very simple. What you have to do is, you have to make it a closed figure, a polygon that is bounded by straight lines. That is bounded by straight lines. So you simply have to draw a straight line like this to close the figure, right? You don't have to draw 2 or 3 lines. You don't say like, I'll draw one line like this, and then I'll close the figure. No, it's not your choice. You have to draw a single line to close the figure. Are you getting it? It means for 3 vectors, you will get a quadrilateral because you'll close it by only one side, only one straight line, right? Only one line segment. So it will become a quadrilateral. So now we have obtained the resultant vector according to Polygon law vector addition. We have these 3 vectors, A1 vector, A2 vector and A3 vector, and we have drawn the 4th line to close this figure, right? Now according to Polygon law vector addition, this side which you have drawn to close this figure is the resultant vector. This is the resultant vector. Now the natural question is, how is this possible? Where did we get this law from? This we'll discuss later. First see that this side will represent the resultant of these 3 vectors, right? Now the question is, if this is the resultant, then since it is a vector quantity, it must have a direction. So here we have 2 possibilities, this or this. So same like triangle law of addition of vectors, the resultant vector will be just in the opposite order in which these vectors are arranged. Like if you see, the order is A1 vector, A2 vector, A3 vector, then this will be the same order. Are you getting it? So the Polygon law of vector addition, same like triangle law of addition of vectors, says that the resultant will be represented by the closing side in the opposite order. So we saw this is the same order. So no, this will not be the resultant vector. This will be the resultant vector. So here, according to Polygon law of vector addition, this will be our resultant vector. This will represent A1 vector plus A2 vector plus A3 vector. So easy. Are you getting it? You simply have to draw a closing side to make it a polygon, and then you have to draw the direction of the arrow. How will you draw the direction? Looking at the order in which these vectors are arranged, which you are adding. A1 vector, A2 vector, A3 vector. So this will be the same order, right? So not in the same order, in the opposite order. So this will be my resultant vector, right? So this is Polygon law of vector addition. So proceeding in the similar manner, let's look for 4 vectors, 5 vectors and so on. Let's check. Suppose I have 4 vectors arranged in the same order like this. Suppose this is 1 vector, this is 2nd vector, this is 3rd vector, this is 4th vector, let's say. Now I have changed the order intentionally so that you understand that whether it is in anti-clockwise or clockwise, that doesn't matter. They must be in the same order. Here also head and tail, again head and tail, again head and tail. Are you getting it? So they must be arranged in the same order. So these vectors are arranged in this order, right? And here we have 4 vectors. So let's call them, this is A1 vector, this is A2 vector, this is A3 vector, and this is A4 vector. And we want to find the resultant, means we want to calculate the vector summation of these 4 vectors, A1 vector plus A2 vector plus A3 vector and plus A4 vector. This is what we want to find, right? Vectors must be in the same order. So they are already in the same order. Now we want to find the resultant of these 4 vectors. So what we have to do, we have to draw the closing side to make it a polygon. So simply take this point and draw a line segment. This is polygon law of vector addition. This will represent my resultant. Now the only challenge is to find its direction. So see, the order is like this. This, then this. This will be the same order, right? So you don't have to go in the same order, in the opposite order. So draw it like this. Are you getting it? So now this will represent my resultant vector. It's so easy, right? So you can write here A1 vector plus A2 vector plus A3 vector plus A4 vector. So this will be my resultant vector, right? Again, let's check for 5 vectors quickly. Suppose you have one vector like this, one vector like this, one vector like this, 1, 2, 3, one vector like this, 1, 2, 3, 4, and one vector like this, let's say, right? Now you might have been thinking, are they in the same order? Yes, they are in the same order. Tail, head, tail, head, tail, head, tail, head, tail, head. Are you getting it? Or you can see it like this. They are flowing in the same order, same order. Anywhere you see the arrow is directed along the same sense. Are you getting it? Or simple is tail head, tail head, tail head. You can check it like that. Okay. So now I have 5 vectors. 1, 2, 3, 4, 5. Let's name them. Now it's A is already done. Now let's call this is B1 vector. This is B2 vector. This is B3 vector. This is B4 vector. And this is B5 vector. And what you want to find is resultant of these 5 vectors, means vector summation of these 5 vectors. So this is B1 plus B2 plus B3 plus B4 and plus B5. This is what we want to find using polygon law of vector addition. So it's very simple. What you have to do, you have to convert it in polygon by drawing the closing side and only one straight line, not as many as you want, right? So you take this point and this point and draw a straight line. It's so easy, right? Now the only thing is you have to draw the direction of the arrow, direction of the vector. So see, the sense is like this. The sense is like this. So the same order will be this, but not in the same order, in the opposite order. So draw just opposite to this. So this is what will represent B1 vector plus B2 vector plus B3 vector plus B4 vector and plus B5 vector. This will represent my resultant vector, right? You must have observed a pattern, right? So I think by now you must have developed the definition of this polygon law of vector addition. See, for 3 vectors, what you got is a quadrilateral. The 4th side you had to draw, right? For 4 vectors, 1, 2, 3, 4, the closing side is 5th side. So you are getting a pentagon, right? For 5 vectors, 1, 2, 3, 4, 5, the closing side is the 6th side. You are getting a hexagon. Now, don't get confused with regular pentagon and regular hexagon, because usually when we talk about pentagon and hexagon, the same figure comes in our mind, that regular ones. Not necessary. Penta means 5, gun is side, I think. So pentagon is 5-sided polygon, hexagon is 6-sided polygon, right? So similarly, for 6 vectors, you will get 7-sided polygon, that is heptagon. For 7 vectors, you will get 8-sided polygon, that is octagon, and so on. So for n vectors, The closing side will be n plus 1 side. So for n vectors, the n plus 1 sided polygon in general, if you talk in general, you have to generalize all these, then you will say for n vectors, the n plus 1 sided polygon will represent the resultant vector, and that n plus 1th side, the closing side, will be the resultant in the opposite order, right? So before proceeding any further, still we have to discuss a lot in this. Let's write the statement of this Polygon law of vector addition. So this is the statement of the Polygon law of vector addition. And if n vectors are represented by the n sides of a n plus 1 sided polygon. So let's look till here. If n vectors are represented by the n sides of a n plus 1 sided polygon. So see here, n vectors, a1 vector, a2 vector, a3 vector, a4 vector, a5 vector, and so on, continued till an vector. Means how many vectors we have? N vectors. Now this is the closing side, this blue one. So this polygon is not n sided, it is n plus 1 sided, because you already have n vectors and you have drawn one more line segment. So this becomes n plus 1 sided polygon, right? Now these sides of the polygon represent the magnitude, that is the length corresponds to the magnitude of these vectors, and the arrow orientation or the direction represents the direction of these individual vectors. So that is what is being said here. If n vectors are represented by the n sides of a n plus 1 sided polygon in magnitude and direction, in magnitude and direction, right, with all the vectors arranged in the same order. This is the most important thing. Here all the vectors are arranged in the same order. Tail head, tail head, tail head. You understand that. All the vectors are arranged in the same order. Then the resultant of these n vectors, will be given by the n plus 1 side or the closing side of the polygon in the opposite order. Here the order is like this. The vectors are arranged in this order, right? So the same order will be like this. This is the same order. So this vector, if it was in this direction, then it will be called as same order. But here the direction is like this, so in the opposite order. So this closing side or n plus 1th side of this polygon, the n plus 1 side or the closing side of this polygon will represent the resultant of these n vectors, right? So this is a universal law applicable on any number of vectors. Whether you have 3, 4, 5, 10 millions of vectors, doesn't matter. The only thing, they must be arranged in the same order, right? N vectors implies n plus 1 sided polygon, and all n vectors arranged in the same order, right? Alright, so let's look at some examples quickly to see how do we use this Polygon law of vector addition in practical situation. It's not like you'll find vectors already arranged and that too in the same order for you to simply apply the Polygon law of vector addition, that is drawing the closing side and taking its direction in the opposite order. It doesn't happen usually. It's rarest of rare cases that you'll find vectors arranged like this, right? And that too in the same order, and you simply have to draw this closing side and you get the resultant vector. It generally doesn't happen, right? So what all possibilities are there and how will we use this Polygon law of vector addition in those cases? Let's look at that. And before beginning this, let me tell you, this Polygon law of vector addition is the universal law for addition of vectors. It can be used for any number of vectors and wherever the vectors are present, doesn't matter. You can always arrange them in the same order and you can always apply the Polygon law of vector addition. So see, here we'll be using parallel shifting of vectors frequently in many problems. While using this Polygon law of vector addition or triangle law of vector addition, we'll be required to use this parallel shifting of vectors, right? Okay, so let's look at these examples. Example 1, example 2. How do we use this Polygon law of vector addition, right? You won't get vectors arranged in most of the cases, and that too in the same order. So let's look at this example. We have four vectors: A vector, B vector, C vector and D vector, and we want to find the resultant, right? So we can use Polygon law of vector addition. So the first thing about Polygon law of vector addition, the vectors must be in the same order. So first check whether vectors are in the same order or not. So A vector and B vector, they are in the same order. Now C vector is not in the same order, that is in opposite order, right? Again D vector is in the same order. So here one thing is clear, you can't use Polygon law of vector addition directly. You'll have to make some changes, right? Without changing the vectors, right? You can shift them anywhere in the space, keeping them parallel to their original direction. That you can do. You can't change the length and orientation, nothing like that, okay? So let's use parallel shifting of vectors and first bring these vectors in the same order. So how can we do that? See, I can bring this D vector here at this point where the head of C vector is. I am shifting it parallelly. So I have brought D vector here. See carefully. So this is my D vector. I have drawn it parallel to its initial direction and try to keep the length same. So you have to keep the length same. You don't have to change the vector. This is very important. So now this is my D vector, right? So I can remove this one because I have brought the same vector here. So now this does not exist for us. D vector has already been brought here. Now C vector, it can be shifted parallelly and now linearly in the same direction. So first I am bringing it here. See, keeping the length same, orientation same, right? And now in the same direction, right? So now C vector is finally brought here. You have to keep two things in mind. Neither the length should change nor the orientation. So I have kept it parallel and same length, right? So now my C vector is here. Now my C vector is at this point. So same like D vector, I can remove this C vector also because now it is already shifted at this point. Now you see A vector, B vector, D vector, C vector. A, B, C, D is not important, right? A, B, D, C, that is fine. The order should be, the order of the vectors should be same. So whether you add A plus B plus D plus C or you add A plus B plus C plus D, same thing, right? So now these all four vectors are in the same order because tail head, tail head, tail head, tail head. They are in the same order, right? Now you have only one thing to do. What is that? You have to draw the closing side. So take these 2 points and draw a straight line, right? Now the only thing is direction. So opposite order. So the order is like this. So this will be the same order, this. So I have to go just opposite this, right? So now you get A plus B plus C plus D. So what you saw here, in this case, example number 1, the vectors were arranged, but they were not in the same order. So it is possible to bring them in the same order by parallel shifting, and then we can use Polygon law of vector addition. Got it? So example number 1 was like vectors are arranged, but not in the same order. In example number 2, neither vectors are arranged. So where we can talk about the order, forget about order. The vectors are not arranged, right? They are scattered in the plane or a space, right? So here we'll have to shift all of these vectors. We can keep one of the vector at the same position. For example, if I keep F1, then I'll have to shift this 1, 2, 3, 4 vectors, right? And the purpose will be to bring them in the same order. Then only we can use Polygon law of vector addition. So see how to bring these vectors in the same order. So F1 vector is here. I can keep this F4 vector here, or F3 vector here, or F5 vector here, or even F2 vector here. That is completely your choice. First I am bringing this F3 vector here. So for example, you brought this F3 vector here, right? So F1, F3, F2 vector, you can't keep it here, right? You can place F5 vector. f5 vector. Yes, this f5 vector I have kept it parallel, right? And this f3 vector is already here. So f3 vector I have brought here. This f5 vector is here, right? This is f1 vector. This f4 vector you can keep here. F4 vector. Check it. Are you getting this point? F4 vector I have placed here. Okay. Okay, one thing I see, this f3 vector and f5 vector seems almost parallel. So you can do like this. You can keep it like f5 vector. This is f5 vector, right? And this is f4 vector. And don't think like how will we know that whether they are parallel or not. The directions will be given in the question. This I am doing a freehand diagram just to make you understand. Otherwise in the questions it will be given like this angle or this angle, right? So if the angles are same, means they are parallel. So don't worry about that. So this is f1, f3, f5, f1, f3, f5 I have placed here. f4 is here. f2 I have to make it parallel. So this is almost parallel, right? Yes, and same length. So the whole purpose is the vector should not change, right? Here I am drawing a freehand diagram, so the length and the orientation can change slightly, but the concept is this, and that you have to keep in mind, that neither length nor orientation, nothing of that should change, otherwise vector will change. You can shift them parallelly, that is a freedom, like I said before. So see, we have placed all these 5 vectors in the same order, 1, 2, 3, 4, 5, right? Now for applying Polygon law of vector addition, the first condition is already met, that is all these vectors are in the same order. Now you have to make it a closed figure, that is polygon, by drawing the closing side. So how will you do that? So I take this point and draw a line segment between these 2 points. This will represent my resultant vector, but in the opposite order. So the order is like this, right? So this is the order. Are you getting it? So the same order will be this direction, but you have to take opposite order. So this is the order. So this will represent my f1 vector plus f2 vector plus f3 vector plus f4 vector plus f5 vector. Are you getting it? Now while I was drawing, you might have got a different arrangement, right? You might have thought a different arrangement. Why is it mandatory that I should bring f3 vector here, right? I can bring f2 vector here after f1. That is completely my choice. Absolutely correct. So you can go that way as well. You are going to get the same result, right? You are getting vector here, resultant vector, by this arrangement. You might get it somewhere here or here or here or here, whatever, but you'll find parallel to itself and of the same length. This is necessary. This has to happen. All right, so how do we get this law? Means what is the proof of this? So let's prove it. And as usual, let's begin with the simplest case. Here again I have taken 3 vectors like I took in the beginning. So let's take 3 vectors and see it how we can prove it for 3 vectors, and then we'll extend the same concept on 4, 5 or any number of vectors, right? So let's begin. See, what we have to find is the resultant of A vector, B vector and C vector. Means we are adding these 3 vectors, right? A vector plus B vector plus C vector, right? So can we do like this? First of all, I'll find the resultant of these 2 vectors only, means A vector plus B vector, right? And whatever resultant I get from here, the same I'll add with C vector. So A vector plus B vector is the first step, and whatever resultant I got, I'm adding with C vector is the second step. So A vector plus B vector, you'll get first step, and then whatever resultant you got, you add with C vector, then you'll get the resultant, that is A vector plus B vector plus C vector, right? This is what we can do. So see, I'm going to add 2 vectors first, that is A vector and B vector. And for this, you can use either parallelogram law or triangle law of vector addition. So see, this A vector and B vector, they are in the same order. So we can use triangle law of vector addition. So let's draw the third side of the triangle. So let me take this point and this point and draw a straight line. This is the third side of the triangle, right? So this will represent the resultant of these two vectors, but in the opposite order. So this is the order. So opposite, this will be my resultant vector. Are you getting it? Or simply, tail should touch tail and head should be at the head. Tail at tail, head at head. So this is my A vector plus B vector. So the first step is complete. We have obtained the resultant of these two vectors. Now we simply have to add the resultant with C vector. So this is my resultant, A vector plus B vector. Now forget about A vector and B vector. We have already added them and we have obtained the resultant of these two vectors. Now this is what is to be added to C vector to get A plus B plus C. Are you getting it? So now see carefully, this A vector plus B vector and C vector. Again, these two vectors are in the same order. Tail, head, tail, head. Are you seeing it? Now see this vector, not these ones. A plus B vector is like this. The head is here. And C vector is like this. Tail of C vector is here. So they are in the same order, right? Again, we can use triangle of vector addition. So A vector plus B vector is one side and C vector is the other side of the triangle. So we have to draw the third side of the triangle. So take this point and this point, right? And draw the closing side of the triangle or the third side of the triangle. So the resultant will be this side, of which two vectors? A plus B vector is one vector and C vector is the second vector. So the sum of this is this vector, but in the opposite order. So this is the same order. So this will be my opposite order, right? Are you getting it? So this will represent A vector plus B vector plus C vector. This is one vector, this is another vector. Now see the Polygon law of vector addition. What Polygon law of vector addition says, that if vectors are in the same order, arranged in the same order, then the resultant of these vectors will be given by the closing side of the polygon in the opposite order. The vectors are in the same order, so in the opposite order, right? So here we have obtained the resultant of these three vectors by using triangle law of vector addition in steps. So see, if you remember, we got triangle law of vector addition from parallelogram law by simply introducing one more concept, that was parallel shifting of vector. And from triangle law of vector addition, we are getting Polygon law of vector addition. So what is the most basic law of addition of vectors? Parallelogram law of addition of vectors. Parallelogram law of addition of vectors gives triangle law of addition of vectors, and triangle law of addition of vectors being used in steps repeatedly for many vectors, it is giving Polygon law of vector addition. The same concept we can use for 4 vectors, for 5 vectors, and for any number of vectors. So let's generalize this by looking at n vectors. Okay. Alright, so now let's look at the proof of this law for any number of vectors and then generalize it, right? So now we have n number of vectors. N can be anything, 10, 50, 100, 1,000, millions, right? So we have n number of vectors, right? All of them are arranged in the same order, right? And we want to prove Polygon law of vector addition, which says that the closing side of the polygon will be the resultant in the opposite order, and that is what we have to see. So we already know triangle law of vector addition. That is what we are going to use in steps, stepwise, right? We'll get the Polygon law of vector addition. So see, here I have n number of vectors. So what I'll do is, first I'll add a1 plus a2 vector. Whatever resultant I get, I'll add with a3 vector. So I'll get some resultant again. This is one vector, this is another vector. So you'll get some resultant. So whatever resultant you get, you add with a4 vector. So now this is my one vector and this is another vector. Again, I'll get some resultant using triangle of vector addition. Whatever resultant I get, I'll add with A5 vector. So this represents now one vector, right? Because all have been added, so there will be some resultant. So this is one vector being added with A5 vector. So that will give another vector resultant. So whatever you got till A5, you add with A6 and go on continuing. A time will come when you'll get the resultant of these all vectors plus dot 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 means A5, A6, A7 and so on. So a time will come when you have already added till an minus 1, right? So all of those vectors added will give a resultant. You have to simply add with the final vector an vector. So you'll get the resultant of all these vectors, right? So this is what we are going to do in steps. For adding two vector quantities, we'll be using triangle of vector addition like we did for 4 or 5 vectors, whatever we had taken in the previous example, 3 vectors, right? So see here now, this is A1 vector, this is A2 vector, they are in the same order. So let's find the resultant by drawing the third side of the triangle. So this is one point, this is another point, draw the third side of the triangle. This will represent my resultant in the opposite order. So this is the same order, opposite order. Now I am doing it fast because you already know it. So this will represent A1 plus A2 vector. Now forget about A1 and A2. We have already added them. A1 plus A2 is one vector. This is another vector. So A1 plus A2 vector is like this. A3 vector is like this. Again in the same order. So draw the third side. This is one point. This is another point. So this will represent my resultant of A1 plus A2 and A3. So this will be A1 plus A2 and A3, right? And what will be the direction? In the opposite order. So this is same order. So this will be my opposite order, right? Now A1 plus A2 plus A3 is one vector and A4 it is another vector. We have two vectors. They are in the same order. So we can draw the three side according to third side according to triangle of vector addition. That will represent the resultant. This is my third side. They are in the same order. This will be the same order, opposite order. So A1 plus A2 plus A3 is one vector. So A1, A2, A3. This is one vector added with the second vector, that is A4 vector. This will be my resultant. Right? All right. So now we obtained A1 plus A2 plus A3 plus A4. So go on continuing like this, right? So a time will come when you have already added an minus 1 vector, right? And since these all vectors are in the same order, so this will be in the same order. So this is like this and this is like this, right? So the resultant will be this side in the opposite order like this, A1 plus A2 plus A3 and so on till an minus 1. Are you getting it? Right? So now we have this as one vector, which is the resultant of vectors till n minus 1, and this is the second vector, an vector. So we have two vectors now, this, and they are in the same order. So the resultant will be given by the third side. So this is one point, this is another point. Draw the third side of the triangle. Vector like this, vector like this. So the same order will be this, so opposite order. This will represent the resultant of these two vectors. One is this, another is this. So one vector is the resultant till n minus 1 and the second vector is an vector. So you can write A1 plus A2 plus A3 plus so on till n minus 1. This is one vector, this side. Are you getting it? And the second vector is an vector. So this side will represent the resultant of these two vectors. Resultant till n minus 1 and an means A1 plus A2 plus A3 plus dot 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 till an. This is the resultant of n vectors. So this is what is polygon law, that all the vectors are in the same order. So the resultant will be given by the closing side of the polygon, not in the same order, in the opposite order. So now we have proved polygon law of vector addition for any number of vectors, right? All right. Now an important question. This is a common query among students, that for using Polygon law of vector addition, is it a necessary condition that the vectors which you are adding must be coplanar? When suppose you are adding 6 vectors, so is it necessary that all those 6 vectors should lie in the same plane? If you are adding 10 vectors, is it necessary that they must lie in the same plane? Then only you can use polygon law of vector addition. So the flat answer is no. How I am saying this? So you need to use only 2 concepts. What is that? One is triangle law of addition. Plus second thing is 2 vectors are always coplanar. So one thing is clear. These 2 vectors are always coplanar. This we have already done in the previous lectures. Using parallel shifting of vectors, we had proved that whether 2 lines are parallel or intersecting, or neither parallel nor intersecting, that is skew lines, they can always be brought in one plane. So 2 vectors are always coplanar. This we have already proved in the previous lectures, right? In types of vectors. So 2 vectors are coplanar, always coplanar, and triangle law of addition of vectors. These 2 things we are going to use to prove that it's not required for the vectors to be coplanar for applying polygon law of vector addition. Alright, so now see, while proving this polygon law of vector addition, we have simply used triangle law of addition of vectors multiple times in a steps. Means at a time you are using only triangle law of addition of vectors. Means you are adding only 2 vectors, right? And 2 vectors are always coplanar wherever they are present in the space, like we did for vectors scattered, means at different places, and we put them in the same order, right? So similarly, wherever the vectors are present, they are coplanar. 2 vectors, if you take 2 vectors at a time, they are coplanar. So you can apply triangle of addition of vectors for 2 vectors. Means at a time you can apply triangle of addition of vectors for any 2 vectors wherever they are present. Are you getting this point? So a1 plus a2 vector, once you have got this a1 plus a2, now forget about these 2 vectors, whether they are coplanar with a3 or not, doesn't matter. Now you are concerned only with a1 plus a2, which is one vector, and a3 another vectors. Now again you have 2 vectors, so they will always be coplanar. They can always be taken in a plane. These 2 vectors can always be taken in a plane, right? So only that much is concerned. So again you will add these 2 vectors, applying triangle of vector addition, you will get this law. You will get this resultant, right? So now whether a1, a2 and a3 are coplanar or not, or whether they are coplanar with a4 or not, doesn't matter. You have obtained a1 plus a2 plus a3, which is one vector, and a4 is another vector. So this vector and this vector, they will be coplanar. There will be a plane which will be common for both of these vectors. Are you getting this? So again you can add them using triangle of vector addition. So in this way you can go in a steps using triangle of vector addition in the same way like we did before. So at the end you are going to get only these 2 points. One is the first vector's tail and another is the final vector's head. So you'll be drawing this same line segment between these 2 points, and you have to take in the opposite order using triangle of vector addition. So now you should forget this, that vectors should be in the same plane. They must be coplanar for using polygon law of vector addition, not any such condition. Vectors can be coplanar or not in the same plane, doesn't matter. We can apply polygon law of vector addition on them. Are you getting it? So now we can really say that this polygon law of vector addition is universal. Wherever the vectors are present, whether they are coplanar or not, whether they are arranged in the same order or not, whether they are even arranged or not, doesn't matter. You can do all of them, and finally you have to be concerned about only the closing side and the opposite order. Got it? So this is all about polygon law of vector addition. Alright, so now we understand what is polygon law of vector addition, what is the statement of the polygon law, how we can use this polygon law to add any number of vector quantities, and wherever they are present, doesn't matter. Even if the vectors are not arranged in the same order, we understand that using parallel shifting, we can arrange them in the same order and then we can apply Polygon law of vector addition. Then we have also proved Polygon law of vector addition. So now we are in a position to apply those concepts on real problems. So let's look at some questions. So this is question number 1. So I'm showing this question on the screen. I'll give you 5 seconds. I'll show all the questions because suppose you are not able to read the question clearly. So I'll show it on the screen. I'll give you 5 seconds. If you want to take longer, you can pause the video and read the question carefully and then we solve it. Alright, so this is the question. Okay, so the question is, which of the following is or are true about the Polygon law of vector addition? So we have written some statements, 4 statements about the Polygon law of vector addition. We have to see which of these statements is or are true, right? So let's check it. It is an extension of triangle law of vector addition. We saw that we used triangle law of vector addition to prove this Polygon law of vector addition. Right, so it is an extension of triangle law of vector addition. We saw in the discussion that we use triangle law of vector addition for 2 vectors in a steps, and we went on doing that repeatedly and we finally got the Polygon law. So Polygon law is nothing but simply an extension of triangle law of vector addition. So this is true. So this is true. It can be used to add any number of vectors. Yes, there is no limitation as how many vectors you want to add. You can add any number of vectors, right? So this is also true, right? Now, Polygon law cannot be used if vectors are of different magnitude. No, there are no such rules. Any number of vectors and with any magnitude, any orientation, doesn't matter. Like if this vector is this much length, then there is no any such rule that the next vector should also be of the same length. No. It can be of this length, it can be of this length, it can be even smaller, it can be even bigger, doesn't matter. The resultant you will find like this. Alright, so this is false. This is false. There is no such rule about magnitude of the vectors which are being added for Polygon law vector addition. No, so this is false. Now, Polygon law is used for coplanar vectors only. Again, we proved it in the discussion that there is no such restriction that vectors must be coplanar, then only you can apply Polygon law vector addition. No. So again, this is false. Because Polygon law is used for any type of vectors, it need not be coplanar, right? So our options will be A and B. Got it? Alright, so question number 2. So look at your screen and read it carefully. So here is the question. Okay, so find the resultant of the vectors forming a hexagon as shown in the diagram. So these are the vectors given: F1 vector, F2 vector, F3 vector, F4 vector, F5 vector and F6 vector, right? These vectors are forming a hexagon, right? This is not a regular hexagon. It's nowhere mentioned in the question. So there is nothing like these sides are equal, right? What you see here, these all vectors, right, are in the same order. They are all in the same order. So it is forming a closed loop, right? So here we have 6 vectors forming a hexagon as shown in the diagram here. All vectors are in the same order: tail head, tail head, tail head, tail head, tail head, right? So we have to find the resultant, means we have to calculate vector summation of F1, F2, F3, F4, F5 and F6, right? So this is what we need to calculate. Okay. So you can proceed it like this. See, we can use Polygon law of vector addition directly here. Look at this carefully. If I add from F2 to F6, don't add F1 right now. First add F2 to F6. For example, I start from F2 plus F3 plus F4 plus F5 plus F6. So from F2 till F6, all the vectors are in the same order. So we can use Polygon law of vector addition. So the closing side will be the resultant of these 5 vectors in the opposite order. So the order is like this. So the resultant vector will be in the opposite order. Order is like this. So like this. Means the closing side. So from here till here, you will have to draw a line segment, right? In the opposite order, right? So this is, this black one, the resultant of F2 till F6, right? The resultant of F2 till F6 is of same length as F1 vector, right? And in the opposite direction as with respect to F1 vector, right? F1 vector and this vector, they are in the opposite direction. So can you say that this vector is a negative vector of F1 vector? So this whole thing can be written as minus F1 vector, right? And you are adding this quantity with F1 vector. So what will you get? 0, null vector, right? So the interesting thing is, it's not only about these 6 vectors or 5 vectors or 4 vectors or 3 vectors. This is a general rule for any number of vectors. If they form a closed loop or a polygon with all of them being in the same order, then the resultant is always going to be a 0 vector. Okay, so this is question number 3. So look at your screen and read it carefully. This is your question. Okay, so 3 vectors, d1 vector, d2 vector and d3 vector related to the motion of a particle are shown in the diagram below. Here, calculate the following. So let's look at the diagram. This is d1 vector, d2 vector and d3 vector. These vectors are related to the motion of a particle. So maybe this d1 vector, d2 vector, d3 vector representing displacement of the particle or velocity of the particle. Whatever it is, doesn't matter. We have to see them as vectors. That's it. So for us, this d1 vector, d2 vector and d3 vector are simply vectors, right? So what we have to calculate? Magnitude of the resultant vector. So we have to calculate the magnitude of the resultant vector. That is d1 vector plus d2 vector plus d3 vector, the resultant vector mod of this, the magnitude of the resultant vector, right? And then the angle between the resultant vector and d1 vector. So we don't see the resultant vector here, we'll find it. So once we find, then we have to calculate the angle of that resultant with respect to this d1 vector, right? The first one is magnitude of the resultant vector. So first of all, we need to find the resultant vector, right? So this is d1 vector, this is d2 vector, this is d3 vector. So you see all these 3 vectors are in the same order. So we can use the Polygon law of vector addition directly here. So 3 vectors, so the 4th side, it will be a quadrilateral. We have to draw the closing side to form a polygon. So this is the closing side, right? So this is the order of the vectors. So in the opposite order, or simply head on head and tail on tail, right? So this is my d1 vector plus d2 vector plus d3 vector. So now we have shown that arrow which represents our resultant vector, but we have not calculated its magnitude. Now we have to calculate the magnitude of this vector, right? Oh my God, I have forgotten to show you the angle. This angle is given as 30 degree and this angle is given as 60 degree in the question, right? So this d2 vector is aligned at an angle of 30 degree with respect to d1 vector, and this d3 vector is aligned at an angle of 60 degree with respect to d2 vector. So now we have shown the resultant vector, but we need to find the length of this resultant vector, that is its magnitude. So how to do that? So let's use some geometry. See, if I extend this line, and then extend this d3 vector further, you see, with respect to d1 vector, d2 vector is aligned at an angle of 30 degree, right? And with respect to D2 vector, D3 vector is aligned at an angle of 60 degree. So what is the angle D3 vector makes with D1 vector? First is 30 degree, then 60 degree. Total is 90 degree. So this is going to be 90 degree. Do you see that? This is 90 degree. You can also check like this. This is 60 degree. So this will be 60 degree, vertically opposite angles. So in this triangle, 60, 30, 90. So this angle has to be 90 degree. Total angle 180 degree. So let me write here P. Okay. So now you see this ADP is a right angle triangle. And of this right angle triangle, AD is the hypotenuse. So now we can use Pythagoras theorem if we know the length of PD and this PA, right? So already it is given mod of D1 vector is D, mod of D2 vector is D, and mod of D3 vector is 2D. So now this is D, this one is 2D, sorry, D, and this D3 vector mod of this is 2D, right? So first of all, I am finding this length DP. So this is already 2D, you need to calculate CP. So CP is nothing but this length sine of 30 degree. Same like resolution of vector. You can use trigonometry, right? So this is D. So this much length, this C to P is nothing but D sine 30 degree, right? And for this length, D to P, this one, BP, is D cos 30 degree. So this is D cos 30 and this is D sine 30. Same like resolving the vector. And if you don't know how to resolve the vector, you can use trigonometry. Cos 30 is base upon hypotenuse, sine 30 is perpendicular upon hypotenuse. You will get the same result. You simply have to find base and perpendicular, right? So now let's find PD. So PD is nothing but 2D plus D sine 30. Sine 30 is half, so this will be D by 2. So this becomes 45D, 5D by 2, right? Now let's find this PA. This PA, the base of the right angle triangle, perpendicular we have already calculated. So this is D plus D cos 30. D plus D cos 30. Cos 30 is how much? Root 3 by 2. So that is D 1 plus root 3 by 2. Right? So now we can calculate the magnitude of the resultant vector D1 plus D2 plus D3. We can find it like this. D1 plus D2 plus D3 vectors, mod of this is nothing but root of 5D by 2 square plus D square 1 plus root 3 by 2 square. You can expand it and get the result. D square common in both, so we can take it outside. Root of this will become 25 by 4 plus this will become A plus B, expand it, A plus B square. So this will be A square plus B square plus 2AB, so that will become root 3. So how much you get? You can add it further, you will get the magnitude of the resultant vector. So this will give the magnitude of the resultant vector. The second one is the angle between the resultant vector and D1 vector. Means we need to calculate this angle, right? You see, this is the resultant vector. So this is the tail of the resultant vector. This is D1 vector. So this is the tail of the resultant vector. So for finding the angle between the two vectors, first of all, tail or head should touch each other. So here tail and tail touch each other. Now we have two angles, this one and this one, the smaller one. So this is the angle we need to calculate. Let's call it alpha, right? So can you find the value of alpha? So in this right angle triangle, alpha can be calculated as tan alpha is perpendicular, that is PD, upon base, that is AP. So let's write it. Tan alpha is perpendicular, which is PD, that is 5D by 2, upon base, that is PA. PA is D 1 plus root 3 by 2. So D 1 plus root 3 by 2, right? So D cancel. Here you can cancel 2 as well. 5 by 2 into 2 upon 2 plus root 3, right? 2 is the LCM for these two. So 2 plus root 3, 2 plus root 2. 2 to cancel, you get 5 upon 2 plus root 3. So root 3 is 1.73 plus 2, that is 3.73. 5 upon 3.73. How much will be the value? This will be approximately 1.34. So that will be somewhere around 52 degree or 53 degrees, something like this. So we don't have to calculate this much. We can stop here. We can write alpha is equal to tan inverse of 5 upon 2 plus root 3, right? Alright, so this is what we had to do in this video lecture. We'll again meet in the next video lecture with a new topic. Till then, take care. Bye-bye.